Here is the graph of the function y is equal to 1 over x, and x is positive, greater than 0. And what I'm interested is given any point on the graph, let's say I'm right over here at some x value a and some y value 1 over a, so this point right here would have coordinates a 1 over a, where a is positive. If I form a tangent line to this point, tangent to this curve, I am going to something like that. Okay, and I am interested in what the area of this triangle is. Okay, so now I don't need integration to do this question. You could, but it's not necessary. However, one does need to know how to take derivatives. So let's see what we do here. We want to find, first of all, the equation of this line, okay? That is tangent to this function, the graph of this function at a point given to us. And we do that with derivatives. So first we need to find the slope. So if y is equal to 1 over x, then that means dy over dx is equal to minus 1 over x squared. If you write 1 over x as x to the minus 1, then dy over dx, you just have this minus 1, you bring it down, so you have minus x, and then you take 1 away from the exponent, so minus 1 minus 1. This equals to minus 2. And x to the negative 2, you can just move it downstairs. So that is the slope. And at the point, or if I say, if this is f of x, then this is going to be f prime of x. And it means that at f prime of a, the slope is going to be negative 1 over a squared. Right? If a is positive, then the slope is negative 1 over a squared, which is going to be a negative value, which makes sense because my slope, this line, tangent line, is going downwards as we move to the right. So that's my slope. So then if we want to find the equation of this tangent line, we can use the point slope formula. Y minus my y value, which is 1 over a, and that is going to equal to my slope, f prime of a, which is negative 1 over a squared, times x minus a. Okay, so this is the point slope formula. I'm given the slope, negative 1 over a squared, and I'm given the point x and y. X is a, y is 1 over a. So that is cool. So in order for me to calculate the area of this triangle, I should be able to know what the height and width of this triangle is in this first quadrant. So what I'll need is the y and x intercepts. Okay, so let's find the y-intercept. So for y-intercept, what is that? So y-intercept, we set x to equal 0. So that's how we obtain the y-intercept, because it's on the point is on the y-axis, and the x coordinate, the x value has 0, okay, in that coordinate. So when we set x equal to 0, then we get y minus 1 over a is equal to negative 1 over a squared times negative a. This can be simplified to just 1 over a. So then the negatives cancel out, right? And then a and this 1a in the denominator cancel out. So we're left with 1 over a. So we move the negative 1 over a to the right-hand side. So we have 1 over a plus 1 over a. If we add 1 over a on both sides, we get 2 over a. So when x is 0, y is 2 over a. So that is going to be my y-intercept right here. So we have 0, comma, 2 over a. So now if we want to find the x-intercept, what we do is we set y to be equal to 0. So when y is equal to 0, from this equation, we have negative 1 over a is equal to negative 1 over a squared multiplied by x minus a. Right over here, what I can do is multiply negative a squared on both sides. So I'll get a is equal to x minus a. Okay. Then what that means is if I add a on both sides now, I get 2a is equal to x, which means x is equal to, oh, that's it. Yeah, 2a is equal to x. So then when x is 2a, y is 0. Okay. So there I found my y and x intercepts. And now I can find the area of this triangle shaded in red. So the area of a triangle, that is just equal to base times height over 2, or you can say 1/2 base times height. Base times height, let's see, so base is 2a, my height is 2 over a, and that is all over 2. There are several ways to do this, but if you start with the numerator, you have 2a multiplied by 2 over a. The a's will cancel out, so you'll get 4 divided by 2, which gives you 2. Or you can see that the a's in the numerator cancel out, and then the 2's cancel out, and then you're left with 2. In the end, the answer is 2. So it actually doesn't matter what a you give me, if you let a be 5, if you let a be pi, if you let a be square root of 2, if you let a be 1 over 1,000, as long as a is positive, the tangent line to that point, a 1 over a, and when it intersects with the two axis, the y-axis and the x-axis, okay, the area that is bounded by that line, the tangent line, y minus 1 over a is equal to negative 1 over a squared times x minus a, that line, and then the x-axis and the y-axis, that area bounded by those three lines will always, it will give you a triangle, and that triangle would have an area that is always equal to 2. So I thought this problem was very interesting indeed. So yeah, this was pretty cool.